Welcome students. Today our topic is conductor and sag calculation. In electrical engineering we are using various conductor and we have various type of conductor materials available, like we have a copper, we have aluminum, like various type of conductor or conducting materials are available, but they have some properties by which we are using in a transmission, like the conducting material have low resistivity and it has the high conductivity. The conducting material also have the low temperature coefficient of resistivity. It also have the good thermal conductivity. It should be easily available, environmentally stable, should be highly ductile, easy to get in shape, rod and wires, and economic viability. It is the must. If our material is too costly, then we are not supposed to use in our transmission or distribution line. So we have various type of electrical conductors in which we have hard drawn copper, all aluminum conductor, all aluminum alloy conductor, aluminum conductor steel reinforced, aluminum conductor aluminum alloy reinforced, ACSR, and the bundle conductor. From these six we are using ACSR, aluminum conductor steel reinforced, in majority. So we have a view of the conductor. We have the ACSR conductor, which is we can see the stranded conductor. We can see that we have a various type of conductor outside. It is aluminum, and we have a steel outside it and aluminum inside. So it is overall make the ACSR conductor. And when we look to the solid versus stranded conductor, the solid conductor is just like a solid wire, and stranded conductor is made from the different or we can say that multiple conductor, and we can twist it. So it will form a stranded conductor. In a picture you easily see it is the solid conductor and it is the stranded conductor. From multiple stranded solid conductor we make a stranded conductor. Now in the solid conductor it consists of a single piece of metal wire. It is cheap for manufacturing. Skin effect is higher in a solid conductor, as at a higher frequencies current flow on the surface of the conductor result in the increase in effective resistance. The main disadvantage of the solid wire is it is more rigid property. It cannot be bent easily. So from this to overcome this disadvantage, we using stranded conductor, and this stranded conductor or stranded wire consists of subconductors touch each other. It is costlier to manufacture compared to solid wire for the given current carrying capacity. The size of the stranded conductor is large as compared to solid wire. When we look to the type of conductor, we have a majority 4 types of conductor. We have a solid conductor, we have a stranded conductor, we have a hollow conductor, and we have a bundle conductor also. So solid conductor and stranded conductor, we know in the main purpose to use a hollow conductor is that in the hollow conductor the skin effect is very low, because the majority of current is flow on the surface of the conductor. When we talk about the skin effect, the majority of the current is flow on the surface of the conductor. So we use hollow conductor. Now in the solid conductor, the cross section of the solid conductor are small because it is very difficult to handle it due to higher weight. And when we talk about the stranded conductor, it is used in transmission line, and the number of conductor we can decide by the formula n is equal to 3 n plus 1 plus 1, where n is a number of layers. When n equal to 0, then n equal to 1, and we, as per the changes the value of n, the capital N or we can say number of conductor in the standard conductor, we can easily calculate it. And by this we can also calculate the diameter of the conductor also. the diameter of the conductor D is equal to 2n plus 1 into D. So by vary the value of 0, we can calculate the value of D. So the diameter of hollow conductor is large as compared to solid conductor for same current carrying capacity. The corona loss is eliminated due to large diameter of conductor. The skin effect in hollow conductor is less as compared to stranded conductor. We already discussed. And when we talk about the bundle conductor, it is defined as the two or more than two conductor per phase. So it is known as a bundle conductor. If we looking to the transmission line in the field, so we see that in a single phase, two or more conductors are in a single phase. So it is termed as a bundle conductor. The advantage of the bundle conductor is that low corona loss due to large cross section of the area, low inductance per phase due to higher GMR. GMR is the geometrical mean radius, which reduce net reactance of the conductor, and power transmission capacity increases as reactance of the line decreases, or one included, it also increase the reliability of the supply. Now for the conductor size selection in a power distribution, both aluminum and ACSR are commonly used. Mostly aluminum conductor are used in the distribution system because of its cheaper cost. Some of the following factors which decides the conductor design for distribution system, these are current carrying capacity of the conductor or distribution line. So as per the current carrying capacity, we select the conductor size, allowable voltage drop or line regulation. As per that, we are also selecting the conductor, and the breakdown strength of the conductor. Now the factors affect for the distribution cable selection, these are the maximum continuous current rating, system earthing, voltage drop, condition for installation, expected short circuit level of system, temperature rise, and the economic evaluation. For all these things, a factor we are considered for distribution of cable selection. Now for the sag calculation, we are one terminology we are continually using, that sag and the span. In the when we talk about the power system or the transmission and distribution system, we are continuously using the terminology sag and the span. So a span is the difference between the two pole. It is known as span, and the sag is the dip of the conductor between the two level support. It's called sag. So in a picture you easily see the sag and span, and in other words, the vertical distance between the highest point of the electrical pole or tower and the lowest point of the conductor between the two adjacent level is known as sag. Now few factors are affecting the sag, that is the conductor weight. The conductor has definitely have some weight, and because of that the conductor will fall. So the sag of the conductor is directly proportional to its weight. The weight of the conductor is increased due to the ice loading. So the conductor have weight, so it will just dip in the span. So it will definitely conductor weight will affect the sag. Then sag is directly proportional to the square of the span length. Longer span gives more sag. Next is tension. The sag is inversely proportional to the tension in the conductor. Higher tension increase the stress in the insulator and supporting structures. Next is wind. It increases sag in the inclined direction. And temperature, the sag is reduced at low temperature and it increases at the high temperature. Now when we talk about calculate the sag, so we took our two supports. It has a sag of S and tension T is there, and when we look at the point and here, and distance of this point is X, and the distance between the two poles or the span length is L. So consider X meter of the conductor between midpoint O and point N. The two external act on the portion ON on the conductors are the tension T act at point O and the weight of the conductor of x meter length, that is W x acting at x by 2 meter from point N. Now, equating the moment of the above two forces about point N, we get Ty is equal to Wx into x by 2 or y is equal to Wx square by 2t. At point P, y is equal to s. If you look to the figure, y is equal to s. Then x is equal to L by 2. Then we again put this value into this. Now, then s is equal to W L by 2 whole square upon 2t is equal to W L square by 8t. So, this calculation is for when the supports are at a same level. Now, it is not occur every time. Sometimes we have a support at a different level because we have a hilly area too. So, when we have a different support area, we have a S1 here, S2 here, A and B is there, and the difference between these two supports, or we can say the height difference between is h. So, the more sag or a lowest point will be near about the lower support or a lowest height support. So, so between this point to this A is x and the span between A and B is L. So, the remaining distance is L minus x. So, from the higher level support is L minus x. S1 is equal to Wx square upon 2t and S2 is equal to W L minus x square upon 2t. Difference in two level supports H is equal to S2 minus S1, and now we get the value. So, from this 2TH is equal to WL square minus 2WLX, or 2WLX is equal to WL square minus 2TH, or X is equal to L by 2 minus TH upon WL. So, from this we calculate the value of X and put this in the equation, and we get the value of H also. Now, the ice and the wind is also affect this sag because it increase the weight of the conductor. If the conductor weight increases, then the sag will definitely increases. The weight per unit length of conductor is changed when wind load or wind blow at a certain force on the conductor and ice accumulate around the conductor. Wind forces act on the conductor to change the conductor cell weight per unit length horizontally in the direction of the airflow. Considering wind forces and ice loading both at a time, the conductor will have a resultant weight per unit length. Now, when we talk about the ice and wind loading, we took the cross section of the conductor, like it has a diameter of d, and we take the ice loading and wind loading. So, here R is the ice loading. So, in this condition, the weight of the conductor together with weight of ice act vertically downwards. Thus, total weight act on the conductor per meter length is Wc plus Wy. Wc is the weight of the conductor we took in kg per meter, and Wi is the weight of the ice loading per meter. Now, let the diameter of the conductor is d and R is the thickness of the ice. Then the total conductor become d plus 2r. Then the volume of the ice loading per meter length of the conductor is equal to pi by 4 d plus 2r square minus d square. Then we get the value of the volume of ice loading. So, the density of the ice is approximately 920 kg per meter cube. So, the weight of ice per meter length Wi is equal to 920 into pi r d plus r per kg. So, we get the figure of the weight of ice coating per meter length. Now, in the case when we have a combined effect of wind and ice, so the ice definitely increase the weight of the conductor, and the air pressure also increase the weight of the conductor. Due to this, the overall weight of the conductor increases and the conductor will swing also. Under this condition, the weight of the conductor together with weight of ice act vertically downwards, while the wind loading acts horizontally. We have a phasor diagram which include the ice and wind loading and the weight of the conductor also. So the resultant will be increased. Now then the resultant weight per meter length of conductor included ice coating and wind forces are WR under root WC plus WI whole square plus WW, where WW wind force in kg per meter length, which is equal to wind pressure per meter square of projected area into projected area per meter length, which is equal to P into D plus 2R. Then we calculate, therefore we have a maximum sag WR L square upon 8T. So by this we calculate the effect of the ice and the wind also on the conductor, and we calculate the sag. Now suppose we have a 132 kV transmission line which has the following data. Then weight of the conductor is 680 kg per meter per kilometer. Length of span is 260 meter. Ultimate strength is equal to 3100 kg, and safety factor is 2. Now we have to calculate the height above the ground at which the conductor should be supported, and the ground clearance is 10 meter. We have a ground clearance around 10 meter. For this, the working tension T we have to calculate, which is equal to ultimate strength by the safety factor. Ultimate strength is equal to 3100 by 2. Then we calculate the tension, which is equal to 1550 kg. Now weight of the conductor per meter length, W is equal to 680 by 1000 is equal to 0.68 kg. Now maximum length, we put the value of W and T from this. So we get the sag which is equal to 3.7 meter. Now the height above ground at which the conductor should be supported. Now we have the clearance which is equal to 10 meter, and we have a sag is equal to 3.7 meter. So we added both. So we get the answer which is equal to 13.7 meter. So we similarly like that we have too many numericals on the sag tension calculation. Now here it is a stringing chart. This stringing chart shows the relation between sag temperature and the tension. It is clearly that if the tension increases, our sag decreases. If tension increases, our sag decreases. If temperature increases, our sag also be increased. So next we have a transposition of conductor also. The transposition is a physically rotation of the conductor so that the conductor is moved to take up to the next physical position in the regular sequence. The transposition of the conductor equalize the mutual inductance and capacitance between the lines. The regular or the irregular spacing between the conductor gives a complex value of inductance which makes the study of the power system complex. So the transposition is mainly done in the switching station and the substation. The transposition cycle is shown as the figure below. That is, we have R, Y and B. We can say that, or we show by 3 different color. That is, in a first sequence we have position 1. This conductor is going here. In second, it goes in a second position. In a third stage, it is on the last position, and again it will be in a next stage. It will definitely go in the first position again. So similarly like that, we transpose the conductor. Now the need of transposition conductor is that the inductance of the unsymmetrical line causes voltage drop even if the voltage is in a balanced condition. So from this we have a need of transposition of the conductor. The transposition of the line can be done by placing the 1/3 segment of all 3 phases of the conductor in the same line. The disadvantage of the transposition is that the frequently changing the position of the conductor weaken the supportive structure, which increase the cost of the system. So it is a disadvantage of the transposition of the conductor. Now when we look to the factor affecting sag, we already said that that is conductor weight, span, tension, wind and the temperature. These all 5 are the factors to affect the sag. That's all for today. Next topic we are discussing in next class.